Welcome to Star Technology 5G. In the last video, we studied how to interface 4x4 matrix keypad with PIC16F877 microcontroller. In today's video I will show you how to display temperature using analog to digital converter ADC0804. Let's start the video. Please subscribe to the Star Technology 5G and click on the bell icon. Analog to digital converter devices. Analog to digital converters are among the most widely used devices for data convert. Digital computers use binary values, but in the physical world everything is analog. Temperature, pressure, and velocity are a few examples of physical quantities. A physical quantity is converted to electrical signals using a device called transducer. Therefore, we need an analog to digital converter to translate the analog signals to digital numbers so that the microcontroller can read and process them. As you can see in the following diagram, in the physical world everything is analog. But microcontroller only understand digital data. We need analog to digital converter to convert the analog signal to digital so the microcontroller can understand. ADC0804. In this project we are interfacing the ADC0804 using PIC16F877 microcontroller. ADC0804 is a single-channel analog to digital converter chip. It takes only one analog signal. It has 8-bit resolution. If ADC has higher resolution, it gives smaller step size. If ADC has 8-bit resolution, input voltage span is 0 to 5 volts and the step size is 19.53 mV. 5 volt divided by 255. Here is pin configuration of ADC0804. CS, chip select. It is an active low pin. RD, red. It is an input pin and is active low. WR, right. It is an input pin, clock in. External clock source pin, INTR. Interrupt pin, V in positive, analog input to ADC. V in negative. Analog input connected to ground. A GND, analog ground connected to ground. VREF2, reference voltage. Used to set the reference voltage. Default reference voltage is 5 volt when not connected. Step size can be reduced by using this pin. DGND, digital ground connected to ground. D7 to D0, output data bits of binary data. CLKR, clock reset. VCC positive supply voltage. Conversion. Send a low to CS pin, CS equals 0. Send a low to high pulse to WR pin to start the conversion. If INTR equals 1 conversion is not finished, wait until it is finished. If INTR equals 0 conversion is finished. Ensure, send a high to low pulse to RD pin to read the data from the ADC. Project. How to display temperature using ADC0804 and LM35. In this project, we will connect 8 bits analog to digital converter IC ADC0804 with PIC16F877 microcontroller. We are using an analog temperature sensor IC LM35 and its output connects to an ADC0804. We will interface LCD with port C and ADC interface with port D of the PIC16F877 microcontroller. The temperature will display every 5 seconds on LCD. Here is the circuit diagram we are using in our project. It is PIC16F877 microcontroller. Pin number 1 is master reset. If we press the switch it will reset the microcontroller. Port B interfaced with LCD data pins. Pin RC0 interfaced with EN pin of LCD. Pin RC1 interfaced with RW pin of LCD. Pin RC2 interfaced with RS pin of LCD. Pin VSS connect with ground. Pin VDD connect with positive 5 volt. Contrast pin VEE connect with variable. And the value of the variable is 5 kilo ohm. It is analog to digital converter ADC 0804. All data pins DB0 to DB7 interfaced with port D of the microcontroller. Pin RC5 interfaced with CS pin of ADC. Pin RC6 interfaced with RD pin of ADC. Pin RC7 interfaced with INTR pin of ADC. It is LM35 temperature sensor. V analog positive pin interfaced with output of the LM35. V analog negative pin interfaced with ground volt. Clock reset pin interfaced with 10K resistor. Clock in pin interfaced with 150 PF capacitor. VREF interfaced with variable resistor and its value is 1K. Pin numbers 13 and 14 interfaced with an 8 MHz crystal. And 22 PF capacitors connected with the crystal. Pin number 11 and 32 connected with positive 5 volts. Pin number 12 and 31 connected with ground volt. Let's draw this circuit in Proteus. The circuit is ready now. We will write its code in Mikro PIC. Here is the window where we can write the code. I already wrote the code, otherwise video gets very long. I will copy the code. And I will paste it here. Now I will define you the code. Hashtag define LCD port B. Define port B as LCD. Hashtag define ADC port D. Define port D as ADC. S-bit EN at port CB0. Define enable pin at port C pin RC0. S-bit RW at port CB1. Define read write pin at port C pin RC1. S-bit RS at port CB2. Define RS pin at port C pin RC2. S-bit RD underscore ADC at port CB5. Define ADC RD pin at port C pin RC5. S-bit WR underscore ADC at port CB6. Define ADC WR pin at port C pin RC6. S-bit INTR at port CB7. Define ADC INTR pin at port C pin RC7. Void MS delay. Unsigned char time. Define delay function with variable name time. Unsigned char. Y, Z. Define variable name Y and Z. 4. Y equals 0. Y less than time. And increment Y. For loop for delay. 4. Z equals 0. Z less than 254. And increment Z. For loop for delay. Void delay. Unsigned char time. Define delay function with variable name time. Unsigned char. M. Define variable name M. 4. M equals 0. M less than time. And increment M. For loop for delay. Void LCD CMD. Unsigned char X. Define LCD CMD function with variable named X. LCD equals X. Send data to LCD. RS equals 0. RS pin equal to logic 0. RW equals 0. RW pin equal to logic 0. EN equals 1. EN pin equal to logic 1. MS delay 5. Call delay function. EN equals 0. EN pin equal to logic 0. Void LCD data. Unsigned char X. Define LCD data function with variable named X. LCD equals X. Send data to LCD. RS equals 1. RS pin equal to logic 1. RW equals 0. RW pin equal to logic 0. EN equals 1. EN pin equal to logic 1. MS delay 5. Call delay function. EN equals 0. EN pin equal to logic 0. Void LCD string unsigned char asterisk str. String send function. While asterisk str. Stay in this loop while data not finish. LCD data. Asterisk str plus plus. Send data to LCD one by one. Void LCD ini void. LCD initialized function. MS delay 250. Call delay. We used maximum delay because LCD needs some time to power on. LCD CMD 0x38. Call LCD command function and give hex value 38. Set LCD in 8-bit mode, 2-line mode and 5x10 dots. LCD CMD 0x0C. Call LCD command function and give hex value 0C. Set LCD display on. LCD CMD 0x01. Call LCD command function and give hex value 01. That is command for clear LCD. Void convert display. Unsigned char value. This function convert binary code decimal to ASCII code and display on LCD. Unsigned char x1 x2, x3. Define variables. LCD CMD 0xC4. Call LCD command function and move cursor at position number 5. x1 equals value divide by 100. And take reminder with 10. This line find the 100 digit and copy that digit into x1. x1 equals x1 plus 0x30. Add 0x30 into x1 and copy result into x1. This line convert data into ASCII code. x2 equals value divide by 10. And take reminder with 10. This line find the 10 digit and copy that digit into x2. x2 equals x2 plus 0x30. Add 0x30 into x2 and copy result into x2. This line convert data into ASCII code. x3 equals value take reminder with 10. This line find the digit and copy that digit into x3. x3 equals x3 plus 0x30. Add 0x30 into x3 and copy result into x3. This line convert data into ASCII code. LCD data x1. Call LCD data function and print x1 data. LCD data x2. Call LCD data function and print x2 data. LCD data x3. Call LCD data function and print x3 data. LCD data 0xdf. Call LCD data function and print degree sign. 0xdf is code of degree sign. LCD data c. Call LCD data function and print c. Unsigned int temp. Define variable. Void, main. Main function. TRISB equals 0x00. Set port B as output port. TRISC equals 0x00. Set port C as output port. TRISD equals 0xFF. Set port D as input port. LCD INI. Call LCD initialization. MS delay 200. Call MS delay. INTR equals 1. Set INTR pin at logic high. RDADC equals 1. Set RDADC pin at logic high. WRADC equals 1. Set WRADC pin at logic high. LCD string temperature. Call LCD string and write temperature on LCD. While 1. Repeat forever loop. WRADC equals 0. Send logic low to WRADC pin. MS delay 10. Call MS delay. WRADC equals 1. Send logic high to WRADC pin. While INTR equals 1. Wait for end of conversion. RDADC equals 0. Send logic low to RDADC pin. For reading data from ADC 0804 we need to send logic low to RD pin. Temp equals copy ADC data into temp. RDADC equals 1. Send logic high to RDADC pin. It will stop reading data from ADC 0804. Convert display temp. Call convert display function, convert ADC data into temperature and display on LCD. MS delay 254. Delay between next cycles. Now we will create the hex file. Just click on the build icon. Finished successfully. File is created. Now we will load hex file into the microcontroller. Double click on the microcontroller. Select the hex file. OK. And click on the run simulation. Now LCD show temperature on it. If we increase the temperature LM35, then temperature increase on LCD. And if we decrease the temperature on LCD, then temperature decrease on LCD. If you have any problem with the code, let me know in comments. Thanks for watching. Please subscribe to the Star Technology 5G. And keep watching Star Technology 5G.